let's go through the task. Now, have a look at the task description. It is the dot point that is not in solid color. All right. Now it says perform an investigation and gather information to determine A, which is acceleration, value for acceleration due to gravity, using a pendulum motion or computer assisted technology, which we don't have. And we're using a method I'm going to explain in a moment, and identify a reason for possible variations from the value of 9.8. So basically what this dot point says is this: you will gain values that is not 9.8 exactly on the mark. However, they'll be either averaged out or very similar to 9.8. Okay? An example is last year the closest anyone got, and this was not going to give them an extra mark, it was 9.79. Okay, but that's not going to give them an extra mark. If you got 9.79 and 9.71, they didn't get an advantage. Okay, does that make sense? Yeah. All right. So basically, what you're going to do is you're going to find gravity. And how to find gravity? You're going to conduct a procedure that I've already done the method for. So you don't need to write a method. The only thing you need to do is the results and discussion and a HSC question. Okay. Now the HSC question, if you want to write here, is a 6 marker, so it's 6 marks, right? And it's related to this dot point. Alright, so it's related to it. Now when I talk about related, it means that it could be like a definition of gravity. It could be why is gravity 9.8? Why is there variations? It could be an exam. It could be what do you call it? An experiment that's been done by a student, past student, but it's a HSC exam. Okay. So you're basically not being tested on your method. You're not being tested on how you conduct it in a safe environment, like Snell's law. You're basically the 20% weighting is about your results and your discussion. Now, can I tell you a few things? We're going to highlight today a few equations that, wink wink, you need to remember. Like I'm meaning, those correlate to marks. If you can rearrange these equations, then these will relate to marks. The other thing I'm going to say, and I want this on the video, and this is why I'm recording it, is you need to know how to find gradient. You need to know how to find a gradient. You need to know line of best fit. You need to know how to mathematically work out gradient. Alright? So, I'm just writing on this sheet and this will pop up on the video. But the two things that you might want to write on your sheet is you need to know gradient and line of best fit. Okay? So gradient and line of best fit. You also need to know how to rearrange, and I'm going to go up to those equations now. So for the people that have got these booklets in front of you, can you put them now on your desk? And we'll go through it. So it is from the KISS booklet, measuring gravity is or measuring G is the subtitle. It's in the box. Can you highlight that box for me? Alright, so it looks like this, which is going to be on the web. Okay, so just highlight the box. It says measuring G, and it's got a diagram of something swinging, and it's got a graph in it. Alright. Yeah, so just if it's your book, just highlight the book, okay? Alright. Now, yeah, the whole box. Now, can I explain? In my previous discussion just then, I said you need to find gradient. Can everyone draw their attention to the graph? The graph here shows you the equation for gradient. It is what? T squared divided by the length of string, right? Circle that. So the T squared divided by length of string. So circle that. Alright? And how to find gravity is the equation on the right hand side. See how it says T squared equals 4 pi squared times length divided by G? Then it's rearranged, right? You need to highlight both of those equations. Okay? Now I've got a twitch in my eye. You need to know that. Alright? Yes, so remember that. Now, basically, can I explain the biggest problem, massive problem with students last year? The mass does not matter. If you put a 150 gram mass or you put a 50 gram mass, it does not matter. However, the larger the mass, the less air resistance there is. So less error. Okay, so I recommend you to do more than 50 grams, but you're not going to get a merit if you did half a kilo. Okay, right? Anything around 150 to 250 grams is okay. It all depends on our equipment, basically. So you're going to be making a pendulum. You're going to release it. Now, for it to come back to its original position, that is one swing, and it's got to go 10 times. So it's got to go back to its original position. On its 10th time, you press stop on your stopwatch, you divide it by 10, that's your period. Does that make sense? Alright? Then you do that 5 times. So you're going to go find the period 5 times, find gravity 5 times, and then you're going to find out the average. So if you don't know how to find an average of something, can you remember, you might want to write that down to look that up. It's just basically adding up all your attempts and dividing by the number of attempts. Okay? Is there anything else that I need to share with you? You can look this up on YouTube. There are people with video demonstrations on how to do this. There are HSC questions you can already start looking up around this. Can I explain how important it is for you to be on time and to work in a pair, but to make sure that it's independent? So when you're working with your pair, all you need to do is to gain your period. They find their own gravity, and you find your own gravity. I know it's the same number, but you can't be, being too collusive. Okay, you need to be working independently. All right, so you work in a pair, or if we have a group of 3, that's okay. But I just don't want you to be doing the whole thing together. The other thing is, it's this period in a fortnight, so be aware, if you want to take 15 minutes of your recess, you can, okay? But you can't go past 11 o'clock, okay? So I've got year 9s before it. I'll get my year 9s to set up the stations so you don't have to collect the stuff and so on. The other thing I didn't mention is, you know how I said it's got to swing 10 times, the pendulum? Each attempt you're going to shorten the string. So you're going to shorten the string depending on what you do. Some people did 5 centimeters last year. Some people did 2.5. Some people did 2. It doesn't really matter too much, but you still need to shorten the string. So the best thing is, and now this is the biggest hint, make the string 1.2 meters long, because by the time you tie it up to the retort stand, you're going to lose about 5-10 centimeters by tying. Alright? A lot of people went, oh, I'm going to start at 1 meter. Cut the string to 1 meter. They tied up. Oh, so it's 83 centimeters. I'm like, yeah, because the actual retort stand took some to loop around. Do you get me? So that's a massive problem. And the second problem is, a lot of people don't hold the retort stand down. Because it's got a big mass, this tends to sway, and that's going to affect your results. Okay? Of course, there's going to be errors, but you want to limit them. Okay? That is it. I don't know if is there any questions about it. I suggest to watch this YouTube clip a week before or night before or so on. I suggest you look at how to find a gradient, how to find line of best fit and practice your graphing. And I'll get you to look at past HSC questions. You can already start doing that now, okay? It's all about measuring gravity. You can grab a textbook and you can find questions that may be in the exam. It's worth 20% as well. Now, can I just mention, before I press stop on this, if you get a value that is nowhere near 9.8, be concerned. If it is between 9.3 and 10.5, that is okay. Alright? That's okay. Anything greater than or less than that is massive concern. You've done something wrong. But remember, I'm not here to look at your method. I'm here to help you, okay? So you can ask for help and ask why is this happening. Alright? Is everyone alright with this? Alright? Okay.